Hello everyone. In the previous video, we learned about current and few things related to electric circuit. So as you can see, my first question is, what is current? So should we say current is the power which comes to a house? No. Here, the meaning of current is the flow of matter, flow of water, or flow of wind. How fast or how slow and something is flowing is called as current. If I say it's what is electric current, then I'm talking about flow of electrons. Okay. Now, as you can see, there are a few pictures. Like this is a battery, bulb, switch, and what is this? I didn't discuss about it last time. Okay. If you remember, the current which flow, electric current which is flowing in the circuit or in the electrons, the amount of charge which flows in the electric circuit is measured by ammeter. Okay, so this is the ammeter. Now, what is the symbol that you will be using in electric circuit to represent these four? Okay, these four. If I want to show a battery in a circuit, then what is the symbol? Yes, one big, one small, two parallel lines. The bigger one represents what? Yes, it's the plus sign, means the positive terminal, and the other one is the negative terminal, correct? If I want to show the bulb, how should I show it? Yes, like this. If I want to show a switch, so if I draw like this, sorry, am I correct? Yes, but is this switch on or off? It is off. If I want to show on, then it should be joined like this. Correct? Switch on. And what is this? Yes, this is an ammeter. So what we do, we put it alphabet A in a circle, inside a circle, we put two dashes plus and minus. So these are the electrical circuit diagram for battery, bulb, switch off, switch on, and ammeter. Okay, so this was a short recap of what we did in the previous session, okay, or previous class. Now, next is potential difference. What is the meaning of potential difference? The word difference tells us that there should be a change, right? So what is that? Now, if you keep a horizontal tube and you're just allowing water to flow through it, will it flow by itself? No. Something should push it or something should pull it. That is when water will flow in a horizontal tube. So if I want the water to flow, what should I do? Like in this picture, we have taken the tube a little bit higher. If I keep both the vessels on the same height, the water is not going to flow from first one beaker to the other or from one vessel to the other. So what they have done, they have placed one of the vessel on top of a wall. So you have raised this vessel to a height so that automatically, because of the difference of the pressure, okay, and the gravity, the water will start moving from the top tank to the bottom or from top vessel to the bottom vessel. So if one end of the tube is connected to the tank of water which is kept at a higher level, then due to pressure difference. So what is the difference? Pressure difference. The two ends of the tube in the water, between the two ends of the tube. So what is different here? The pressure here in the tube is higher or more compared to the pressure here. So because of this difference of the pressure, inside the tube between the two ends makes what? The water to move from the vessel on the top towards the vessel in the bottom. So similarly, in a battery or a cell, the electrons or charge do not flow without the pressure difference. Okay. Okay. So have you ever tried to open? Okay. A what? Yeah. What I was trying to ask is, have you tried ever to open a cell or a battery and just have a look into what it is? So there'll be outer cover. Okay, one is the plastic cover. Then there is a metal cover. When you further open it, there is this first part which is the positive terminal, which is a metal cap. The second part is the outer cover. Okay, the third is the carbon black. What is a carbon black? It is a blackish rod which is made of some chemical substance. And these chemical substances are the one which will continuously produce free electrons which are pushed out of the battery. And that is how a battery is able to conduct or pass or allow electrons to flow through it. Okay. And the fourth one is the mesh. Clear? So the electrons or charge in a battery do not flow due to gravity. The electrons will move only if there is a difference in the electric pressure. So what happens is inside this carbon black, there is a chemical substance, as I have already mentioned. The chemical substance will continuously be undergoing chemical reactions, and during the chemical reaction, there will be some electrons which are being released. These free electrons get collected at one end of the battery, and the other end of the battery is not having electrons. So there is this pressure difference. One end having more electrons and the other end having zero electrons. So because of this pressure difference, the electrons will start moving. So this electric pressure difference that is created within the battery because of the free electrons which are released during chemical reaction is called as a potential difference. The potential difference is produced by battery. Okay. So the chemical reaction within the cell will generate this potential difference, as I've already mentioned, across the terminals in the cell. Even when no current is drawn, means even if the cell is not connected in a circuit, if just a cell is lying on the floor, still the chemical reaction is going on inside the cell and free electrons are released, and there is a potential difference between the two terminals of the battery inside the battery, even if it is not connected in a circuit. Okay, hope this is clear. So electric potential difference. What is potential difference? The potential difference was a potential difference within the battery, that is the difference of a number of electrons collected at one end of the battery and the other end of the battery having zero number of electrons. Okay, when such a battery is connected in an electric circuit, what is the battery going to do? It is going to do a work in pushing these electrons through the metal wire or the current carrying conductor, sends it to the bulb, and the bulb glows, and then it again pushes the electrons through the metallic wire and brings it back. So what is electric potential difference? It is the amount of work done that the battery does to push the free electron between any two points in an electric circuit through the wire is known as electric potential difference. So the actual definition is electric potential difference between 2 points in an electric circuit. So let's select one point here and the other point here. So the amount of work the battery is going to do between point B and A for pushing the electrons from B towards A. Okay, how many electrons? Unit charge of electrons from point B to A. That much amount of work is called as electric potential difference. Okay, clear? So let's have a look into the circuit, understand what it is, and then we'll go with the formula for. Okay, as you can see here in this electric circuit, I've already connected the battery. The wiring is being connected. I'm going to put my ammeter to just know how much amount of current is flowing through the circuit, and I'm going to connect my bulb, okay, and the key. Okay, so let's connect it. So once I switch on the once I put the switch on, what do you observe? The movement of the electrons. Right, the blue balls are the electrons which are moving within the circuit. Who is pushing these electrons through the circuit? Yes, it's the battery which is doing the work of pushing these electrons through the circuit between any 2 points, within the bulb or between the two ammeter endpoints or between the two endpoints of the battery. Endpoints of the wire, the electrons are being pushed. Can you see here? So who is pushing this and who is doing this work of pushing the electrons? It's the battery, and that is why it is called as electric potential difference. Okay, so now let us say the potential difference is being across 2 points be represented by V, capital V. W is the work done. Okay, and the amount of charge which is being pushed means the amount of electron which is pushed is capital Q. So the formula for potential difference is work done per unit charge. Per means divided by charge. Okay, so we'll just put the formula for that for the potential difference. Potential difference is represented by V, capital V. Work done is W, charge is Q. So V equals to W upon Q. The unit for W, that is work done, is joules, and the unit for charge is coulomb. Therefore, the SI unit of electric potential difference is volt. Okay, and this was being given by Alessandro Volta, an Italian physicist. Now we'll be looking into what is the definition of 1 volt. The potential difference between 2 points in a current carrying conductor. First of all, whenever we have to calculate potential difference, we have to select 2 points. And between these 2 points, how much amount of work is done by the battery. So because we are defining 1 volt, here we'll say the potential difference between 2 points in a current carrying conductor means the wire. When 1 joule of work is done, to move how much charge? 1 coulomb charge. from one point to the other is called as 1 volt. Okay, so can you see here, this is called as a voltmeter. It can be, the electronic voltmeter looks like this, and a normal voltmeter which are used in the lab, science lab, is this one. And always the voltmeter is connected in parallel, means it's connected across only those 2 points where we have to find the potential. Between which 2 points we have to find the potential. So the potential difference is measured by means of an instrument called as voltmeter. The voltmeter is always connected in parallel across the 2 points between which the potential difference is measured. So let's look into the electric circuit. Okay, and we'll try to place the voltmeter into between different 2 points and find out the reading. Okay. I have not removed any of the connections. Okay, so I'm going to bring a voltmeter now, which is this one. Okay, I'm going to first place it between the 2 endpoints of my bulb. So can you see 18 volt? The current is 1.80. Okay, let me shift the point. Okay, let me put it this and this. So I have changed between which 2 points, right? So it's not showing any reading because it's between the ammeter and the endpoint. So it's not the proper endpoints. Okay, so I should change it. Let's change it between the key and the bulb. So again, it's 18 volt. Okay, so let's place this endpoint there. Why? Because I'm putting the wrong side of the wiring. So I should put this wire here and the wire here. Okay, so the current passing through the wire is not being, the potential difference or the work done by the battery is not being calculated, or it's not shown between the wires, but it is showing between the bulb, right? So this is potential difference. How much amount of work the battery is doing to push the electrons through the bulb is shown by the voltmeter, or and the reading is called as voltage. So as you can see here, again, ammeter is an instrument which is connected in series, which will tell us the amount of current flowing, and voltmeter is an instrument which is connected in parallel across the 2 endpoints to calculate the amount of work done by the battery. So voltmeter shows us the amount of volt passing through the 2 endpoints, and ammeter shows the amount of current passing. Ammeter is always connected in series and voltmeter is always connected in parallel. Hope this concept is clear. Thank you.